Good morning, sir.
Good morning.
Good afternoon. Very good afternoon. You're welcome, sir.
Sorry. Good afternoon. Yeah.
Good afternoon, sir.
Last day of the day.
Yeah. Good afternoon, Sundram Saab.
Namaste, sir. You're
Namaste.
most welcome, sir. We'll just wait for another 5-10 minutes.
No problem. Our colleague,
Yeah.
Dr. Vidhan Singh is also there.
Yeah, good afternoon, Mehta साहब.
Good afternoon. कैसे हैं?
हाँ ठीक है. डॉक्टर साहब नमस्कार. डॉक्टर साहब.
नमस्कार. कैसे हैं आरएम कुमार जी?
This is Mahendra Kumar. डॉक्टर साहब नमस्कार.
Mahendra Kumar.
Dr. Mahendra Kumar. डॉक्टर साहब, I met you in the Krida.
Yeah, I remember, but I am getting confused with your name because your name starts with RM.
RM Kumar, R Mahendra Kumar.
R Mahendra Kumar. Okay, because today I think our office has got call from you.
Yes, sir.
And I could not identify.
Okay, sir. Okay. Thank you, Dr. Saab, for accepting. Thank you.
Yeah, sorry.
Kind of.
Thank you.
Dr. Padmakumari, madam, another 3 minutes we can wait and then start the
Okay, sir. Okay, sir.
sharp at 2:30.
Yeah.
So what is expected time for my talk?
Sir, about an hour, will it be convenient for you, sir?
Okay, no problem.
Because we want to hear more of your insights about mechanization, sir.
Yeah, but I will be talking only about mechanization, and in that also production mechanization, because as you mentioned in your topic.
That will be wonderful, sir. That will be wonderful.
Okay.
And keep it here.
Shall we start, Padma Madam?
Yes, sir. If you permit.
Yeah,
Yes.
you can go ahead, ma'am.
Sir. A very good afternoon to all the dignitaries, scientific fraternity. On behalf of the IIRR and Society for Advancement of Rice Research, I invite you all to this webinar, which is 16th in the series organized by IIRR to commemorate the celebrations of 75 years of Indian independence as Azad Ka Amrit Mahotsav. Today we have with us Dr. CR Mehta, Director CIE Bhopal. Welcome you, sir, who will be talking to us on sustainable mechanization for rice production. Now, I request our director, Dr. R.M. Sundaram, who is also the president, sir, to give his opening remarks. Thank you.
On behalf of Indian Institute of Rice Research and also on behalf of Society for Advancement of Rice Research, I extend a warm welcome to Dr. CR Mehta, a world-renowned agricultural engineer, and also serving as director of Central Institute for Agricultural Engineering at Bhopal. I also extend a warm welcome to all the participants who have joined us for this particular webinar. As you all are aware, mechanization is a crucial input for agricultural crop production and one that is historically has been neglected in the context of developing countries. Factors that reduce the availability of farm power compromise the ability to cultivate sufficient land, and this problem has been long recognized as a source of poverty in many countries, including ours. Increasing the power supply to agriculture means that more tasks can be completed at the right time and greater areas can be farmed to produce greater quantities of crops while conserving natural resources. Applying new technologies that are environmental friendly enables farmers to produce more crops efficiently by using less power. Sustainable agricultural mechanization can also contribute significantly to the development of value chains and food systems, as it has the potential to render crop cultivation, post-harvest, processing, and all other activities linked, and also so that these can function more efficiently, effectively, and environmental friendly. In terms of rice, drudgery is a major factor, and there are many operations still that are being carried out either manually or with the help of farm animals. And rice crop is counted as #1 in terms of drudgery, and there is a significant scope for partial to complete and also customized mechanization in a sustainable manner due to the emergence of new methods of cultivation like wet DSR, dry DSR, etc. I'm sure that today's webinar by Dr. CR Mehta will cover all the aspects of mechanization in rice production in a sustainable manner and will enlighten our audience on a topic that is of interest to all rice researchers. Thank you very much. I now request Dr. Mahindra Kumar to introduce the speakers. Sir Mahindra, sir, you can go ahead.
Sir, thank you, sir. Thank you, sir. Thank you. Thank you, Padma. Sir, I welcome once again our honorable speaker, Dr. CR Mehta ji, for immediately accepting our invitation to be the webinar speaker today. I'm also highly privileged to say a few words about CR Mehta, which is illustrious career, and he has done in PhD from IIT Kharagpur in 2000. He joined as a scientist at same institute, CIE Bhopal. Now he is holding a charge of director of that institute from 27 February 2020. The equip on farm implements and machinery and ICAR-CIE Bhopal were awarded the Chaudhary Devilal Outstanding Award and also All India Coordinator Research Project Award 2018 and Sardar Patel Outstanding ICAR Institute Award 2020 under his leadership. I'll be giving a brief of CR Mehta, but because since we wanted to hear more about his talk, and I'll be very brief. He is also member of technical working group on power tillers of Asian and Pacific Network for testing of agricultural machinery, and sectional committees also. He has done as a member as a in charge for many committees. So he has also received Distinguished Service Certificate 2002 and 2003, Commendable Medal in 2005 and 6, Team Award 2006 and 7, and ISAE Fellowship 2012 and 13 from Indian Society of Agriculture Engineers for Research and Development in the field of farm machinery and power. He also received recognition award during 2019-20 from National Academy of Agriculture Sciences, NAS, New Delhi. He has published over 250 papers, including 40 referred international journals, 21 in referred Indian journals, 3 policy papers, 41 books and book chapters, 40 technical bulletins, and presented more than 100 papers in conferences and workshops. He is a cooperating editor of the Agricultural Mechanization in Asia, Africa, and Latin America. Editor, Indian Journal of Dryland Agriculture Research and Development, editor in Agriculture Missionary, and reviewer of number of international journals. It is all about very brief of Mehta ji. Now I think the floor is open for you, and thank you very much once again for accepting our invitation.
Thank you. So good afternoon, everyone. Respected Dr. R.M. Sundaramji, Director, Indian Institute of Rice Research, Hyderabad. Dr. R. Mahendra Kumar, Professor and Head at ICAR-IIRR. Chairperson of Seminar Organizing Committee, Dr. A.P. Padma Kumari. My friend, Dr. T. Vidhan Singh. I am observing my another colleague from FIM, Dr. P. Rajaya, and scientists participating in this webinar talk. First of all, I thank Director IIRR and Dr. R. Mahendra Kumar for inviting me to deliver a talk on sustainable mechanization for rice production. And if I remember correctly, I have delivered one talk in 2013 on the similar topic at CRRI Cuttack. Now it is NRRI Cuttack. And after that, I haven't specifically delivered talk on this rice mechanization, but overall mechanization and like that. So I thank this group for inviting me. And in today's talk, I will be mainly focusing on production mechanization. For post-production mechanization, I may not talk in my today's presentation, but if this group is interested, that talk may also be organized on some other day. So as you know that around 45% of our workforce is engaged in agriculture. However, it contributes 18% to the GDP of our country, and which shows that our labor productivity is low. If we see that food grain production in India, so presently food grain production is around 315 million ton, and out of that 120 million is of rice crop. So that highlights the importance of the rice crop. And you also know that India is a bottom-up pyramid country, and our 86% of land holding is below 2 hectares. Only 4% of our land holding is above 4 hectares. So we can say that only 4% of our land holding is suitable for individual ownership of farm equipment, and that highlights the need for going for customizing of farm equipment. And the similar is the condition for rice crop also. And you are well aware that India is the second largest producer of rice crop in the world. However, if we talk about the productivity, we lag far behind the developed countries. If we see the labor availability in agriculture, then you may have observed that labor available in agriculture is reducing day by day. And by 2050, we are expecting that around 26% of total workforce will be engaged in agriculture, and that women worker will be more as compared to the male worker, and that will be due to migration of labor from the rural area to urban area to work in industry, to work in service sector, and that will highlight the need for going for mechanization of rice crop. Initially, I am talking about the overall mechanization trend in our country, and then I will be specifically talking about the farm equipment and machinery which are suitable for rice cultivation from production mechanization point of view. In this slide, you can see that if we see the food grain productivity over the years. And if we see the farm power availability, we can observe that there is direct relationship between food grain productivity as well as power availability. So that shows that if we are in a position to complete farm operation on time with the use of mechanical sources of power, then we may get the higher productivity. If we see the trend in this slide about the sale of tractors in our country, then you may observe that the sale of higher horsepower tractors in the range of 31 to 37 kilowatt is increasing over the years, and that is due to the customizing of farm machinery in Indian agriculture. As mentioned by the director ICAR-IIRR, that mechanization level is still very low in our country. And in this slide, you can see that presently mechanization level, overall mechanization for major crops of India is around 45 to 47%. And if we see for rice crop, then it is around 50 to 55%. And in that also, you can observe that the seed bed preparation is majorly mechanized. And if we see about the transplanting operation, it is only around 30%. So that highlights the need for mechanization of transplanting as well as interculture operation for rice crops also. There are some limitations in mechanization of Indian agriculture, and one of them is in India, we have small and fragmented land holdings. Right now, average land holding size is around 1 hectare in our country, and that limits the use of high capacity farm machinery on Indian farms. Another, the role of women worker is increasing day by day. So that also highlights the need for development of machinery which are suitable for operation by male as well as female workers. As well as we have to reduce the drudgery in agriculture by mechanization with the development of machinery which are comfortable to be operated by male as well as female workers. So what is trend in mechanization? Nowadays, we are talking about the smart farm mechanization, and there is need to reduce the cost of ownership of farm machinery because the land holding is reducing day by day. So that highlights the need for going for custom hiring or contract farming, and that can be done using the contract service providers. Like nowadays, app-based custom hiring services is also available, but their penetration is still low. Another thing, we need the good after sales and support service in the rural area also. Then farmers may be interested in using the machinery for cultivation of different crops, including the rice crops. And in that also, now we are working on the development of smart farm machinery. And in my talk also, I will be talking about the smart farm machinery, but those machinery need to be reliable and affordable to be used by small and marginal farmers of our country. Now I will be talking about the different kinds of machinery which have been developed or which are being developed at different institutes as well as SAUs in our country for different farm operations related to crop production, particularly rice crop. So for land preparation, still in some part of our country, land preparation of paddy crop is done using animal drawn equipment, and for that also we have developed the improved patella puddler as well as lug wheel puddler, and that saves the time as well as cost of carrying out the puddling operations as compared to the use of traditional puddlers. I may not go into detail of each and every machinery, but if you have interest in any specific machinery, you may ask me. So I shall try my best to provide the desired information. You are well aware that is for paddy field preparation, particularly in eastern parts, power tillers are also being used. So they are also provided with lug wheel, and those are being used for puddling of the rice fields using the rotary tiller. Then in major part of our country, tractor operated rotavator is used for preparation of field for transplanting of rice in lowland areas. Then you may have observed nowadays use of laser guided leveler for fine leveling of the rice fields. So that helps in saving of irrigation water by around 22 to 25%. And presently laser guided levelers are popular, particularly in northern part of India, but slowly these are getting popular in central as well as southern part of India also, and these are being used on customizing basis. Recently, we have developed the control level puddling system for puddling of rice fields, and for that you may know that laser guided leveler is suitable for leveling of the dry fields, whereas we have developed the control level puddling system for puddling of wet fields, and there we are in a position to maintain the depth of puddling as well as the uniform water level in the fields, and that helps in the saving of the irrigation water for cultivation of rice crop. And recently we have licensed this system to Farm Implements Private Limited, Chennai-based company. Then sowing and transplanting, there are two ways of sowing or transplanting of rice crop in our country. One is dry seeding, another is transplanting of rice seedlings. So for transplanting, still in major parts of our country, transplanting operation is done manually by women workers, and that involves lot of drudgery. So to cover a hectare of an area, women had to insert their fingers in the muddy field around 1.7 lakh times, and that causes the skin problem as well as to work in bending postures that involves lot of drudgery. To address that, we have developed manually operated transplanters, 2-row, 3-row, and 4-row, as well as self-propelled transplanters. So in this slide, you can see the 4-row transplanters. For dry seeding of rice, one seeding attachment has been developed and which can be mounted on the existing cultivator. So it costs only around 40,000. And it is having field capacity of around 0.65 hectare per hour. You may have also heard that DSR seeders are nowadays available, and those are suitable for direct sowing of paddy. And now this year we have observed that around 25% of the total area in Punjab has been brought under the DSR, direct seeded rice, particularly for dry cultivation due to non-availability of labor for carrying out the transplanting operations, as well as limited availability of transplanter in the state of Punjab. So this is for transplanting of root wash seedlings. Also nowadays 2-row rice transplanters are available, and it is having field capacity of 0.04 hectare. Recently, we have modified the commercially available 2-row root wash seedling transplanter. Nowadays, those are being imported particularly from the China, and we have modified it by putting the motor and that is operated by one battery, so that the workers are more comfortable because that is operated by cranking mechanism, and it costs by around 15,000 to 25,000. Paddy drum seeders are also getting popular for sowing of pre-germinated paddy seeder, and for that we have the 4-row unit that is suitable for operation by female workers, as well as we have 8-row unit, and that is suitable for operation by male workers. And here row to row spacing is maintained around 200 millimeter. and it cost from around 4,000 to 5,500 based on the 4-row unit or 8-row unit. Then our OUAT center has developed the pre-germinated self-propelled paddy seeder 8-row unit, and that is operated by a 3 kilowatt diesel engine. And there we are in a position to maintain the row-to-row spacing of around 240 millimeter and hill-to-hill spacing of 120 mm. It had not been commercialized. It had been recently developed and now trials are being conducted. You are well aware that nowadays self-propelled rice transplanter walking type, like in this figure, you can see the 4-row transplanter as well as riding type 6-row as well as 8-row self-propelled transplanters are nowadays available, and those are being used on custom hiring basis, particularly in the southern states of India like Kerala, Tamil Nadu, Andhra Pradesh, and nowadays these are also getting popular in eastern part of country, and even during last 2-3 years, particularly self-propelled walking type transplanters are getting popular in the state of Punjab also due to non-availability of labor for carrying out transplanting operations. And in this figure, you can see the Gyanji Shakti rice transplanter, which had been introduced a few years back, and it cost around 2.5 to 3 lakh. And it is a single wheel rice transplanters, and it uses the mat type seedlings for transplanting. So this is the self-propelled 6-row as well as 8-row units, and nowadays petrol as well as diesel versions of these riding type rice transplanters are available, and those are also being used on custom hiring, but these are costly, and these cost from around 10 lakhs to 15 lakhs. Recently, we have developed the tractor-operated transplanter, and in that actually we have integrated the existing rice transplanting unit of Yanji Shakti with the tractor, and that we have tested, and it has been developed by our PJT SAU Center of AICRP on FIM. And right now we are in the process of licensing of this transplanter. So these transplanters require the mat type nursery, and for raising the net type nursery, we need the rice seeder. So this is the rice seeder. Then recently we have developed the tractor operated rice seeder for mat type nursery, and that has been developed by our PAU Ludhiana Center of ACRIP on farm implements and machinery, and this unit can carry out operations of first bed making, then laying of plastic on that bed of 1 meter, then uniformly spreading the soil on the plastic sheet, then it shows the uniformly spreads the seeds and then covers those seeds also, and all these operations are done simultaneously in single operations of this nursery seeder. So it is having field capacity of 0.11 hectare, and we have also filed for patenting of this equipment, and recently we have licensed it to Messrs. Rajgarh Agriculture Works Limited at Ludhiana. So here you can see the nursery required for transplanting using the rice transplanters. So for that purpose, we have to grow the mat type nursery. So those can be grown in trays as well as on plastic seeds. In some part of India, SRI method of rice planting is also popular. So for that, we have the manual marker also, and we have also made attempt to develop the SRI transplanter, but we are partly successful in that. Recently, we have developed the remote control paddy seeder, and in that we are using the pelletized rice seeds, so those can be sown in the pedal field, and that unit can be remotely controlled using the 12-volt battery. So it is having field capacity of around 0.08 hectare per hour, and we are making an effort to commercialize this equipment also, and it reduces the drudgery of the workers who are involved in transplanting operation, because this can be operated remotely from the corner of a field. You may have also seen that nowadays remote controlled rice transplanters are also being used in developing countries also, like China and Japan. And at our regional center located at Coimbatore, we have made attempt to have remote controlled rice transplanter, and for that purpose we are converting our commercially available rice transplanter so it can be remote control. And nowadays testing of this unit is going on at Coimbatore right now. If we talk about the mechanization of rice, it is not complete if we don't talk about the machinery for conservation agriculture, and particularly rice wheat system, cropping system is followed in northwestern part of our country. So for after harvesting of rice, we have to show the wheat crop, and for that also different kinds of machinery have been developed. So in this slide, you can see that the power tiller operated zero till is commercially available, and that has also been nowadays being used by farmers, particularly in eastern part of country. In this slide, you can see the use of power tiller operated zero till in the eastern part of in the state of Assam. And I shall not go into detail of the machinery, because conservation agriculture machinery, you are well aware that they require minimum tillage, as well as they are suitable for sowing in the residue field. So this is tractor operated zero till. It is very popular, but it requires low straw load in the field. And if we have the high straw load in the field, in that case, we can go for rotary till or strip till, or nowadays happy seeders as well as super seeders are also available. So we have developed different units under different projects. And nowadays, number of such machinery have already been commercialized. So in this slide, you can see the use of happy seeder in heavy residue of rice crop, particularly for sowing of wheat crop immediately after harvesting of the rice crop. And you are well aware that around 4 years back, we formulated one project, Government of India scheme on in-situ management of crop residue. In that, our focus was mainly on promotion of the happy seeders for sowing of wheat crop without after harvesting of the rice crop. So that avoids the burning of crop residue in the fields. And for irrigation and fertigation also, we have come out with different systems. So at our institute, we have developed the automatic irrigation system for rice crop, and that is suitable for alternate wetting and drying methods. So in that, we have float type reed switch. So whenever water level reaches at a particular level, it gives the signals to the controller, and that controller puts on the pump, and then water is irrigated to the field. And whenever water level reaches at a particular level, it automatically puts off. We are making an effort to commercialize this unit also, and it costs around 15 to 20,000 only. We have also tried to study the thermal stress of the rice crop, and on that rice and wheat crop, and on that basis of stress, right now we have developed the thermal imager also, and right now we are in the process of irrigation scheduling, particularly for rice and wheat crops based on the thermal stress of the rice and wheat crops. So that helps in saving of irrigation water. Then for interculture and fertigation, you are well aware that manually operated cono weeder is available, and that is also popular for interculture operation, and this is single row unit, and it is having field capacity of around 0.1 hectare per day, and it costs around 2,000 rupees. Then we have the 2-row finger type weeder. So that is also popular in some part of our country for interculture operation in rice crop, and it is having field capacity of around 0.25 hectare per day, and it costs only around 500 rupees. And nowadays even self-propelled weeders are also available. So we have at our TNA Coimbatore Center of FIM, we have developed the 2-row SRI power weeder. So that is suitable for weeding, and we have licensed this weeding in rice crop, particularly the rice crop which is sown using the transplanter or using the DSR seeder. So we have licensed this equipment, and it is available throughout the country. Recently, on the recommendation of regional committee, particularly which is, I don't remember the regional committee number, particularly which is related to the southern regions, and in that there was suggestion that we have to develop the weeding unit which can be attached to the existing transplanter. So we have developed this ride-on type weeding attachment to existing transplanter, and we have tested it also, and it is having field capacity of around 2.5 to 3 hectare per day. For fertilizer application, still in some part of country, fertilizer is broadcasted. Even manually operated fertilizer broadcasters are also being used. Nowadays, we have the tractor-operated fertilizer broadcasters also, and present, and in some part of country, leaf color charts are also used for recommending the fertilizer dosage for rice crop. And we have also developed the SPED meter for knowing the chlorophyll content of the leaves, and on that basis fertilizer recommendations can be given for rice crop also. And now SPED meter is commercially available from companies like Minolta, and that cost around 1.5 lakh rupees. And we have developed this SPED meter based on the light sensor, which costs around 3,000 to 5,000 rupees. And recently we have licensed this to 3 manufacturers, and this can be used by KVK to give recommendations to the farmers for fertilizer dose to be applied in rice crops. We have also made attempt to develop the variable rate fertilizer applicators for rice crop based on the NDVI value, and that we have tested at our institutes. So this is 2-row unit, and it can apply the urea with an application rate of around 19 to 65 kilogram per hectare based on the NDVI value of the crop at a particular location. For plant protection, you are well aware that manually operated knapsack sprayers are popular in our country, as well as dusters are also being used. Then we have also developed the one sowing cum herbicide applicator unit for paddy crop, and that has been developed by our Bapatla Center of Agripon FIM, and that has been tested, and it is having field capacity of around 0.4 hectare per hour. Nowadays, government is promoting the use of drones in agriculture, and drone is also suitable for rice crop also, particularly for spraying of insecticides. On top left hand side, you can see the drone is being used for spraying of insecticides. And we recently, Government of India has come out with the standard operating procedures for use of drones for spraying as well as nutrient applications, as well as government is promoting the indigenous manufacturing of drones for use in agriculture particularly, and drone can also be used for yield estimation in rice crops as well as remote monitoring of the rice crops. For harvesting and threshing, self-propelled reapers as well as power tiller operated reapers and tractor operated reapers are available in our country, and those are commercialized. So in this slide, you can see the power or tiller operated reaper, then self-propelled reapers, and those are available and having field capacity of around 0.15 to 0.2 hectare per hour. Nowadays, reaper binders are also getting popular, and they cost around 3 lakh rupees, and they cut the crop and then make a bundle of about 5 kg, and that bundle is dropped in the field. So nowadays, self-propelled reaper binders as well as tractor-operated reapers binders are getting popular in our country, and those are having field capacity for self-propelled reaper binder, it is around 0.2 to 0.25 hectare per hour, where a tractor-operated reaper binder are having field capacity of around 0.6 to 0.8 hectare per hour. Vertical conveyor reapers are also available for harvesting of rice crop. So those can be mounted at the front of the tractor. For threshing, this is the traditional practice. So rice crop is trampled under the animal feet, as well as it is beaten on the drum or some wooden sticks also. So here you can see that that kind of manual operations are still being done in some part of our country. In this slide, you can see that even power tiller can also be used for threshing of the rice. And then winnowers, manually operated winnowers are also available, and nowadays motor operated or even power tiller operated winnowers are also available. Particularly in eastern part of country, pedal operated paddy thresher is getting popular, particularly to be operated by women workers. So we have redesigned it from the ergonomic consideration of women workers, and nowadays even motor operated electricity based threshers are also available. And then we, for northeastern region and hilly regions, we have developed the thresher cum cleaner also for paddy crop. So here you can see then that is power operated. Then tractor operated higher capacity threshers are also available, which are on axial flow principles, and those are commercially available and used on customizing basis throughout the country. And those are having capacity from 10 to 15 quintal per hour. Then for harvesting and threshing, combines are also nowadays available. Nowadays, even small combines are also being introduced in our country, but those are not so popular. But nowadays, particularly self-propelled combines, you may see on right-hand side, top right-hand side, as well as tractor on top on the bottom left-hand side. So particularly tractor on top combines are popular in southern part of country, and those are being used on customizing basis in southern part of India, whereas self-propelled rice combines are popular in eastern part as well as northern part of our country. And farmers also want to have the complete straw, and for that purpose, head feed combines are also nowadays getting popular, but those are costly, costing around 20 to 25 lakhs. And those are having field capacity of around 4 hectares per day. For collection of rice, straw combine is available, and that straw can be converted into the bales for use in other industry, or those bales can be stored for feeding to animals during off season also. So for that purpose, racks as well as balers, rectangular balers are popular in northern parts, whereas the round balers are popular in southern parts, and those are of less cost. And nowadays there are a number of manufacturers of such balers in northern part as well as southern part of our country, particularly to avoid the burning of crop residue. So whenever rice crop is harvested in northern part of India, government has made it mandatory that the combine should be provided with super SMS system. So when whatever straw which come out of the combine, that is chopped and uniformly spread throughout the working width of the combine, so happy seeder can immediately follow for sowing of the next crop of wheat. So in the end, I can conclude that there is need for full crop mechanization of rice, and particularly for rice production mechanization machinery are available. Those are being used in some part of country, and there is need for mechanization of different operations, particularly transplanting, interculture throughout the country. Another, the cost of the machinery, particularly which are used for rice cultivation, like rice transplanters, combines are costly, and those are to be promoted on custom hiring basis or on contractual field operations. Another, what is required, particularly in the different parts of the country, there is need for assured mechanized services to the farmers for such machinery. And for the entrepreneurs also need the assured service business for providing such machinery. And particularly, I suggest that for rice transplanter, those should be provided with seedlings also by the entrepreneurs, so farmers may not have to go for growing of the seedlings, and then they may hire the services, because such type of system is popular in Japan, etc. Because there are some cooperative society which provides the rice seedlings of different variety. Farmers can go there, purchase the seedlings, and then they can transplant those seedlings using rice transplanters. Then there is need for strengthening of training facility for rural youth and village artisans on repair and maintenance of the machinery, because nowadays advanced machinery are also being used in Indian agriculture, particularly rice transplanter, combine harvesters, and like recently we have developed the nursery seeder also. So such machinery required the repair and maintenance facility in the rural area, because this is time-bound operation and it had to be carried out on time. Thank you. It is all in brief about my presentation.
Sir, thank you very much, sir. It was a wonderful presentation, and we all appreciate the time and pains you have taken to enlighten us about all aspects of mechanization which are involved in rice production, from harvest even up to the other operations. Sir, Dr. Vidhan Singh will be the moderator for today's session. Dr. Vidhan Singh, are you there?
Yes, sir, I am here.
Yeah. Sir, we can now open the house for questioning, sir. You can invite questions. There are a few questions in the chat box, sir.
Sir, one question is from Dr. Surekha, sir. She wants to know more about this root wash transplanters.
Yeah. Actually, root wash seedling transplanter, whatever nursery which is commonly grown by the farmers, and then farmers go for manual transplanting, those nursery can be used for transplanting using the transplanters. So for that purpose, 2-row transplanters are available. Initially, those transplanters were introduced from China, and a few dealers were there in Maharashtra. But nowadays, in India also we have developed, and recently we have tried to make it motor operated, so so that reduces the drudgery of the workers for cranking of that system, which helps in transplanting of seedlings in the soil.
Sir, I think Dr. Mahinder has a query.
What is
Dr. R.
Namaskar, Dr. Saab.
Namaskar, namaskar.
Dr. Saab, are there any studies at CIA Bhopal regarding that use of drones in rice, especially for dosages of pests and diseases or direct seeding of with the drones? Are there any work is going on at CIA?
At CIA, particularly for rice crop, we have not worked, but our center located at Bapatla,
Okay.
under Angrove, Guntur, and another our center located at TNU have worked on that. Angrove, Bapatla have worked on that around 5 years back, and TNU recently working on different mechanization of different operations using drones, particularly for rice crop.
Sir, taking this point of discussion forward, one of the important operations which is typical of this part of Telangana is hybrid seed production. And presently it is being done manually or semi-mechanically through passing of ropes and other operations, particularly the assisted pollination of the R lines with A lines. So I was just wondering, is there some companies I have seen that they are experimentally using the drones, but I was just wondering your opinion on that, sir, assisted pollination in rice, particularly hybrid rice seed production, sir.
Pollination using drones?
Yes, sir, because it creates a sort of a drift above the plant.
Yeah, that's why that's what I was thinking. I am in doubt that it may be suitable for that, because we have to operate drone at very low speed, and that may not be possible. But for broadcasting of seed, it can be used, and it has been tried also. But pollination, I am in doubt it will be successful, because we have to see the efficacy of the application of pollen.
Yeah. So usually pollination will be done by having one row of the female parent, followed by say about 5 to 6 rows of the male parent. And usually like across the location, it will be only one hybrid seed production that will be taken up. And once probably we'll be getting under a national drone mission. Once we get a drone, probably I think with help from your scientists, I think we can try to standardize.
Yeah. Most of the ICR institutes are getting 2 drones.
So we'll certainly seek your expertise. And then
recently we also got trained our 2 scientists for operation of drones also, as well as an instructor. So
sir, I have one more query. Sir, can I ask?
Yes, sir. Please go ahead.
Yeah. Sir, when we are moving towards increased mechanization, I believe breeders also should breed for those traits which suits mechanization. For example, a variety called Pusa 44 was very highly successful in Punjab as compared to other varieties, because it had a very sturdy stem which stood mechanical harvesting through combine. So like that, there are many operations that are being carried out through machines in rice cultivation. I think it's time for our crop breeders to work along with engineers, and then engineers can give a feedback in terms of what is the plant anatomy or morphology that is required for operation of these machines, so that breeders can target certain traits in the rice plant which suits mechanization. It's my humble
your suggestion is good, and actually we are also nowadays suggesting at different forums that engineers should not work in isolation, or breeders should not work in isolation. We have to work together. Sometimes they have to come out with the variety which are suitable for operation by machinery. For example, for cotton, right now we are looking for a cotton variety which have single maturity, so it can be harvested using cotton pickers also. And even we may require to give some training to farmers also, so they can also grow those varieties which can be different, so that different operations mechanized operations can be carried out for cultivation of that particular crop.
Thank you, sir. Thank you, Rich. Vidhan Singh ji, I think there is one more.
One more question, sir, from Dr. Padma Kumari.
Let me check.
Sir, I'll just read out, sir, for you.
Yeah, I am reading it. No problem.
Okay.
Yes, madam, question is good, and that kind of question is being asked to us at different forums. So in my presentation also, I have shown a few machinery which are manually operated, like a conovidder, then knapsack sprayer, or animal operated, or even self-propelled transplanters. Nowadays, we have self-propelled walking type transplanters, good quality, 2-row and 4-row units. So such machinery can be used on small fields, as well as if we have the contiguous fields. In that case, we may go for even bigger machinery. You may have observed, particularly the use of combine harvester, big size combine harvester on small fields also, and within half an hour, you can harvest your crop. So that will reduce the cost of ownership of farm machinery, because if we own the farm machinery, particularly the small farmers, that may not be economical for them, because that will be having limited use.
In this regard, I have seen excellent surveys done by some companies like ITC and also Syngenta Foundation in terms of purchasing a few medium costing machinery and then providing it for custom hiring. I think in future, it may not be possible for all farmers to acquire some of the machinery, which may be cost intensive. I think just like Ola and Uber, this may also, a model has to be developed. Just by clicking an app, the farmer can ask that particular person to deliver the equipment or operate the equipment. I think that kind of blockchain approach will work really for Indian conditions with respect to mechanization. What is your opinion in this regard, sir?
Your observation is correct. There are number of apps are already available in India, like from Tefe. J-Farm is there, which is getting popular in southern India. Mahindra has launched the Tringo, then EM3. Even government has also launched one app. But right now, penetration of those apps as well as services available from different aggregators are not as good as we are getting the services of Ola and Uber in urban area. But in future, we are expecting that we may get services through such apps throughout the country, because right now only a few service providers or those who are having machinery, they have enrolled with such apps. And in future, we are expecting that we may see in agriculture.
Dr. Krishnaveni, I think you can mute yourself, ma'am.
Okay. So actually in agriculture also, we may see particularly the service sectors, and those will be providing the services of availability of machinery as well as repair and maintenance also through apps. And that will be the future of Indian agriculture.
I think most importantly, we need consultants at a village level wherein they can guide the farmers to the right place to source the right, whether it is improved seeds or machinery or plant protection chemicals or for custom hiring. I think that should be the order of the day. We need consultants, just like in business. Say, for example, I want to develop a startup related to, say, IT. There are several consultants who can offer where to approach, where to get the necessary training, how to apply for a loan with the bank, or how to approach the angel investors. So like that, if we do have the right set of consultants at village or at least at taluk level, they'll be able to guide the farmers, sir. It's my fervent hope that when we train our agricultural graduates, they should also be trained not only as good researchers, but also few should be trained in this particular aspect also, sir. I think Dr. Kannan has a query, sir.
MS Prasad, I think he has.
Yes, sir.
How can the FPO be roped in for using this app and pool their equipment? Kanan. Actually, right now, there are farmers who are having machinery. There are farmers who need machinery. Those are aggregated through those apps. And in the future, some entrepreneurs who may not have land also, and may be interested in going for customizing of farm machinery, they may also enroll through those apps, and they can provide the services. Like in Ola and Uber also, the taxi persons who are who is having taxi, they get themselves enrolled with that particular company, and then they provide the service. The Ola and Uber, they only just provide the platform. They may be having only a few taxis, but others are of other entrepreneurs, those who are running the taxi. A similar service will be in farm machinery sector also.
Thank you, sir. Thank you.
Dr. Rajaya, do you have anything to ask?
Sir, welcome to today's webinar. Rajay Garu, welcome. Most welcome, sir.
Thank you, sir. No questions, sir.
Rajaya has asked me 2 questions in the forenoon.
Are there any more questions from anyone? So if there are no more questions, I request Dr. Padma Kumari to propose a vote of thanks.
Thank you, sir. Before I take over, can you do the honors, sir?
Yeah. I just slipped out of my mind.
Yeah.
Sir, on behalf of Indian Institute of Rice Research and also on behalf of our Society for Advancement of Rice Research, it's my proud privilege to unfortunately, when I have a background, it's actually masking all other things, sir. Sir, it's our honor to give the certificate of appreciation to you.
Thank you.
Kindly delivering this lecture. We will send it by postal services to you so that it will reach you. Sir, many thanks to you for patiently and then very nicely explaining the various aspects of mechanization, particularly sustainable mechanization involved in rice production. Sir, thank you very much. Ma'am, we can go ahead, madam. With the
Thank you. If there are any query, the scientist may ask through email, and we shall try to answer.
Yeah.
Yes.
Thank you, sir.
Thank you.
Yeah, I request anyone who has a query to post their queries to me by mail so that we can put it to sir and get the answers and again transmit to you. Thank you. I earnestly thank everyone for giving me this opportunity to propose vote of thanks. I thank our director and Dr. R.M. Kumar for taking this initiative to invite Dr. CR Mehta, Director CIAE, to deliver this webinar. Sir, I earnestly thank you for accepting our invitation and coming forward and giving this webinar, right from seeding to future projections on the mechanization of from production to protection and mechanization for all these things and the future projections, which will be the future of the day. And I also thank Dr. Vidhan Singh for moderating the session, Dr. Shruti and Tuti for serving as the rapporteurs. I thank all the dignitaries who have participated, from scientists, ex-members of the SAR, life members of the SAR, scientists from sister institutes, technical assistants and students from various institutes, and agricultural officers also. Thank you one and all. And not the least, I also thank our AKMU team headed by Dr. Shailaja for arranging the necessary logistics for conduct of this webinar. Thank you one and all. Thank you.
Padma, we'll have photograph, Padma.
Thank you.
Sure, sir. Sure, sir.
Just you can
I'll ask Shailaja to do that.
take the photograph.
I request each one of you to kindly switch on your webcams.
You have to have light that side. That side light. Mine all directions.
Over, Gayatri.
Okay.
Thank you, sir.
Thank you.
Thank you, sir. Thank you.
Thank you. Namaskar.
Yeah. I declare the meeting as closed. Thank you.
Yeah.
Madam, shall I end the meeting, ma'am?
Please do it, Gayatri. Please.
Okay, madam.